Hi, I'm Navya Majji, and this is my lab on bar magnets. So our introduction to this lab was we were supposed to measure the dependence of a magnetic field due to a small bar magnet and compare it with the results provided by the Biot-Savart law. And we did this with a phone app that had a magnetometer which collected magnetic fields. And a preview of our main result was that we expected was similar to the actual results, which means that the dependence that we expected from this lab was similar to the actual dependence provided by nature. And let's talk about some models and principles used in this lab. So our first one was that the B of the bar is equal to K equals Rn. And K is a mix of constants and parameters and such that doesn't change when we're comparing. So we just have to look at R and N. R is the radius or the distance of the magnet, which also doesn't change. So whenever we changed, whenever we can measure the relationship between the bar magnet and N, which is what we're trying to find, by changing R and seeing how that impacts B. And then the way that impacts it is because of the N value provided. And this is an adapted version of the Biot-Savart law, where this portion, which we usually don't see, I feel, accounts for the vector being 0 or the magnitude being 0 or parallel. And this is our setup for the experiment. So we had to place our phone, which this cross is kind of how we find the magnetometer. And we had to place our phone and either move it sideways or up and down and change the distances in order to find the changing B values from the magnetometer app in order to find the N value. So our situation, our initial surroundings, we limited things that could interact with the experiment, such as the magnets. We cleared the table and we moved away anything magnetic. We lifted the experiment, we put it on top of a book so that it wouldn't impact with any magnets or metals in the table. We tried not to charge anything or have any other technology nearby that could impact it, limited wires and everything. So because of this, we were able to get a magnetometer app reading to go down to 0, as close to 0 as we could get it. We were in the range from -10 to 10, but we tried to fluctuate it. When it fluctuated, we tried to stop it kind of when it hit 0. Some sources of error for this could be that we didn't move things in our surroundings around well enough. We could have changed the position of the phone in the middle of the lab. I feel like there was a lot of movement. So maybe when we were working on an equation or something, we might have moved some of the things and that could have impacted it. Or the reading fluctuated a lot and we might have missed its fluctuation and thought it settled when it hadn't. And another thing was we might have placed this cross incorrectly. So that might not have been properly placed or placed at the same place every time. So moving it around could have impacted that. And let's talk about the results of the experiment. So the template for this was given by the lab, and we were able to change the R and then find average R and the average B. And then when plotted in this graph, ln of B versus ln of R, we were able to find an expected N, kind of an average N, which is given by this line right here. And yeah. So then we had to utilize GlowScript to write code about modeling this so we could see what it should look like. And dipole, this function I wrote based off of the equation given to us in the beginning for Biot-Savart law. And the R mag is just the square root of each component squared. The distances, or finding that, was just thinking about the vector and where everything is located. And then R observation equals R, these parts were also kind of given to us. We had to adapt it for this lab. And one thing that we could have done to make it simpler was just use our observation of the axis as our axis and plug it in here. But rather doing it this way kind of makes it easier to read. But in this situation, because our vector is 0, 0, 0, we could have done that too. Additional discussion. So there were some questions at the end of the lab. And if we had oriented our thing to move to magnetic north, then B cosine of theta is the component that would change, and our magnetic field readings would shift up or down by a few mu Teslas each time. And it would also not work with our B is kind of similar to R of N relationship very well. If we did this, our log plot would be crooked. It wouldn't be as much of a straight line. it would probably have like a bigger slope end or something, and it would be maybe less negative. And then also, if we stuck the magnets together end to end and ran the experiment again, we would double the magnetic dipole moment mu. So we would have 2 mu, which means almost everything would be the same. We could definitely calculate this, but it does kind of impact our K and our K R to the N relationship by, I feel like, ln of 2. And the curve would sit higher at like a factor of 2, but that was